All right, welcome back again, function folks. Day 7 of our trig unit already. There's a lot more to come. This is actually day 3 of our graphing sinusoidal functions mini section. Notice we were asked to do some graphs. This is stuff from yesterday, and in fact, this first one is from yesterday, from last day, so I'm going to skip it. Just look back at last day's note, skip Ola. The next one has got all the bells and whistles. This has got a little bit of everything. Notice that inside here, it's not quite the form that we're used to, right? We're used to seeing it like this. X minus, I think it's minus C plus D. Minus C plus D or minus D plus C, not sure which one. Doesn't matter. Phase shift is this one. You can make fun of me if I get these two letters mixed up. But you see, this isn't right because I don't have the double brackets. This isn't factored. This has only come up about 14 times already this year, and it throws us for a little loop, at least some of us. How we handle that is factor out the inside, right? So factor out the 1/2 and look at what's left. Now, a couple ways to think of this. What number goes here? Well, there's going to be a pi involved. But if I think backwards, after I write whatever's here, it's got to end up with pi over 4 when I multiply it back out. So this is what I'm saying here. Times something, and this is going to be what goes there, has to be pi over 4. Right? When I multiply this back out, well, what's it going to be? Pi, obviously, and 2. And again, if you wanted to get the real actual reason why, you could think of it as, well, pi over 4, and I'm factoring out 1/2. And how do I factor out 1/2? Well, how do I divide by a fraction? I invert and multiply, and that's why it's pi over 2. Either way, now I can see my amplitude. I can see my b value is 1/2, which leads us to a period. The period is stretched by a factor of 2, or I could think of it as 2 pi divided by 1/2, invert and multiply 4 pi. With important points, we think of important points every, not pi over 2, but every pi or every 6 ticks. 6 ticks. Good. And then also, the phase shift is left pi over 2, which is 3 ticks. I'm going to have to fix my graph. I'm going to goof that up. I know what I'll do. I'll just pretend. And then up 1. So how am I going to handle this? I see my scale along the y-axis has to get up to, it starts at 1, has to get up to 3. So this should be okay. That's 3. There's my vertical axis, or my average, or however I want to think it. It's going to go down to -1 here, right? And it's going to go back and forth between these high, middle, low, middle, high, that sort of thing. Need to get the starting spot. The starting spot would normally be at the maximum here, right? This is the middle point where the sine would start, maximum, then move left 3. So I'm going to, not good, left 2, and over here. There's the start. And then, how do I get the pattern? Well, I started high, middle, low, middle, high, right? Every 6 ticks. There's 3, 4, 5, 6, middle. 6, 1, 2, 3, 6, low. 1, 2, 3, 4, 5, 6, and I'm done. Dandy. Hopefully you got something that looks like that, and hopefully you didn't have to graph all of the in-between steps, that you're sort of getting the hang of how graphing trig functions is actually a little bit easier and nicer than the functions like polynomial or rational functions. This part here is little bit of a setup step here. State the period. Well, b is 2. Remember, in each case, this is the period is always 2 pi divided by b, whatever the b value is. So here it's 2 pi divided by 2, which is pi. Here it's b is 4, so it's 2 pi divided by 4, which is pi over 2. And so on. I would have trouble graphing that because the important points would happen in between squares. It wouldn't be too much fun. But this is the point that I'm going to start making. B here is 2 pi. So if I have my period, the period is 2 pi over 2 pi, which is 1. So how would that look? That means this cos graph would start repeating every 1 unit, no pi's. That it would, it would go something like this, there, and then again, and so on. Now, it's not beautiful, but you get the idea. It's the period is an actual real number. And so what about this one here? My b value is 2 pi over 8. And so now if I got, this is kind of weird, 2 pi divided by 2 pi over 8, there's my b value, right? Just, I don't like seeing it like that. I'm going to write it like this. And then how do I deal with fractions? I invert and multiply, and lo and behold, the 2 pi's cancel out, and I'm left with a period of 8. Well, I wonder how that shows up sometimes if I'm clever about the way I write my my b value. Notice if it's 2 pi here, this number on the bottom is just the period, which is going to be awesome when we're thinking about things like pendulums. If it takes a pendulum 8 seconds to get back to its start, then it would be something like this, where this isn't 2 pi or pi over 2 or any pi values. It's actually in seconds, and that's what we're leading into in the next couple of classes. All right, so let's get on with the lesson. Did I mess up those numbers? D and C? No, I didn't. I actually remembered. That was just luck. That was a fitty chance there, and I got it right. Write equations of trig functions given various information. This sounds like what we've been doing the last couple of days, but we'll see it's leading more towards the application end of things, where these will be trig functions in like real life situations. Moral of the warm-up 2. So when I have 2 pi over b, big B, where my little b is this entire value, this big B is the period, right? And if I wanted to figure out then how often the important points are, well, remember, a trig graph gets cut into its 4 quadrants, right? Whether it's a sine or cos. I think of high, middle, low, middle, and then there's the 4 quadrants. 1, 2, 3, 4 quadrants. So these important points occur every b divided by 4 units. So if I wanted to graph that one from the 3-minute review, then I've got my period is 8, and important points are every 8 divided by 4 quadrants is 2 units. Well, so that means this is going to repeat itself every 8 units. It's a cos graph. No amplitude change or phase shift or vertical displacement. Those things are all normal. So what is this going to look like? It's still going to go between 1 and -1, but it's going to repeat every 8 units, right? So if I start here and end here, it's going to be a minimum halfway between, and halfway between that I get my other important points every 2 units. High, middle, low, middle, high. And there's the important points every 2 units. And I can continue this for 2 cycles just like I've been asked. Right? 10, 12, 14, and 16. Every 2 units. B divided by 4. B divided by 4 I get the important points in this non-pi or horizontal axis. There's no pi's along this, and that actually lends itself to the applications pretty easily. What's weird about this, and this is a neat way to remember it, when I see a pi in the equation, there's none on the axis, but when there's one on the axis, there's none in the equation here. There's none in the b value, so it's only one or the other. How am I doing for time? Okay, I'm going to stop there. We'll pick up example 2 in part 2.